In this video, we are going to be looking at multiplying by a monomial. So remember, monomial means that it's one term. So it's a number, a variable, or a product of number and variables. You are going to take your notes in your booklet on page 7, or page 6 rather. Okay, so let's start by just talking about multiplying a monomial times a monomial. So one term times one term. When you multiply monomials, you have to multiply variables with exponents. Remember, to multiply with like bases, you add the exponents. So for example, if I have x squared times x cubed, that gives me x to the 2 plus 3, which is 5. So when you multiply with like bases, you add the exponents. Very important. When you multiply with like bases, you add the exponents. Okay, so when we are multiplying monomials, you're basically going to do two steps, and you do want to write this in the box there. To multiply monomials, first you're going to multiply the coefficients. The coefficients are the numbers in front. Then for each variable, you are going to add the exponents. So you take all the x's and you add the exponents. Sorry. You take all the y's and you add the exponents, the a's, the b's. So for each variable, you add the exponents. Okay, so let's take a look at our first couple of examples. Let's make sure that we all understand what the coefficients are. So in example 1, our coefficients are the 12 and the 5. The 12 and the 5 are the normal size numbers. So I'm going to do 12 times 5, and that gives me 60. No, that gives me 5 times 10 is 50. 5 times 2 is 10, so yes, 60. And then we take each variable. So in this case, it's only the x's. So we have an x to the 5th and x to the 4th. So that's going to be an x to the 5 plus 4, which is 9. Now notice this is different than combining like terms. I'm going to write that over because it got a little messy. Let me try again. So 60 x to the 9. Okay, this is different than our combining like terms. Notice when you multiply with like bases, your exponents do change. When you're adding and subtracting, they do not. So we need to make sure that we're keeping those concepts separate in our brain. When you are combining like terms, when you are adding and subtracting, you have to have like terms. The exponents do not change. When you are multiplying, you can multiply. The exponents do change. Okay. All right, looking at example 2. So I'm going to actually do an extra step on this one just to show you. If it helps, you can do this every single time. And I usually just do it kind of in my head. So what I'm going to do first is I'm going to use my commutative property. Commutative property tells me I can multiply in whatever order I want. And I'm going to rearrange this so that my numbers are together, my a's are together, and my b's are together. So I'm going to rearrange it. I'm going to change this. So right now it's 6 times a to the 4th times b times 4 times a cubed times b squared. Monomial times monomial. I'm going to rearrange it. So I'm going to put the 6 and the 4 together because they're the same. They're both coefficients. I'm going to put the a to the 4th and the a cubed together because they're both a's. And then I'm going to put the b and the b squared together. Okay, now before we actually multiply our coefficients and then for each variable add the exponents, I'm going to remind us here that this is an exponent of 1. So when there's no exponent, it's understood to be a 1. So 6 times 4 is 24. And then a to the 4th times a cubed. That is a to the 7th. When you multiply with like bases, the a's are the same, the bases are the same. You add the exponents. That's a 7. Then for the b's, b to the 1st times b squared is b cubed. Okay, so 24a to the 7th, b cubed. Now again, this step here, you don't have to show it, but that's what you're doing in your brain when you rearrange it. I'm going to show it for the next one as well. just to be super clear. And it's the commutative property that allows us to do that. Okay, so in example 3, I'm going to rearrange. Pause and rewind if you need to. I know I'm going a little fast. So I'm going to first rearrange. So I'm going to pull the 6 and the 3 together, the a squared and the a, and then the b to the 5th times b. Again, on the ones where there's no exponent, it's understood to be a 1. Okay, 6 times 3 is 18. A squared times a is a cubed. Don't know why I can't write a 3 with this thing. Let me try again. Cubed. And then b to the 5th times b to the 1st is b to the 6th. And that is my answer. All right, let's do this last one. So again, monomial times monomial, one term times one term. Terms are separated by addition and subtraction signs. So I've got one term times one term. This time I'm going to skip this middle step and I'm just going to do it in my head. So I'm going to rearrange 4 times 9. Those are my coefficients, 36. The k squared, it doesn't have another one that has the same base. The d to the 5th and d cubed. When you multiply with like bases, you add the exponents. And then the j squared doesn't have another one with the same base. So I get 36 k squared d to the 8th j squared. Okay, if you look at the next page, we have a couple of these examples, monomial times monomial. So number 1, number 2, and number 3. If you want to pause and work those, you can. And then we're going to talk about the distributive property. So if you want to pause and work those, go ahead. Okay. Let's put that back on there. Here we go. Let's look at the next piece of multiplying by a monomial. So when you multiply a monomial, don't know why it's doing that. When you multiply a monomial by a polynomial that's more than one term, see this? 2 terms, 2 terms, 3 terms. So when you multiply by one that's more than a monomial, you have to use your distributive property. So let's recall that the distributive property says a times b plus c is equal to ab plus ac. So distributive property. Keep in mind, when you are distributing, you are multiplying. That's what the distributive property is. Okay, starting with example 1. Here we go. So I'm going to do 5x times x. So it's 5 times 1, which is 5, x times x, which is x squared. Then 5x times negative 2. So it's going to be a negative. 5 times 2 is 10. There's nothing to multiply with the x, so it just stays x. And done. Okay, let's take a look at example 2. Example 2 is written kind of backwards. It's written with the 2y on the right-hand side. If that really bothers you for whatever reason, just rearrange it. Put the 2y up front. Again, that's our commutative property. Tells us we can do that. Tells us we can multiply in whatever order. And now we can distribute 2y times 2y. 2 times 2 is 4. Y times y is y squared. Plus 2y times 3. So that's going to be a positive. 2 times 3 is 6. Nothing to multiply with the y, so 6y. And that is it. We cannot combine these. They are not like terms, so we can't actually do this addition. They are not like terms, so we are done. Okay, moving right along. I'm actually going to move this up just a bit. I'm going to pause a second. Okay, here we go. So, looking at example 3. In example 3, notice I'm doing a monomial times a trinomial, 1, 2, 3 terms. It doesn't change anything except I have to distribute 3 times instead of 2. So here we go. We'll go green. So I'm going to start with negative 3 I'm going to start with negative 3x cubed times 4x squared. So negative 3 times 4 is negative 12. X cubed times x squared. When you multiply with like bases, you add the exponents. Okay? Then negative 3x cubed times 3x. Negative 3 times 3 is negative 9. X cubed times x. Remember there's a 1 there. So that's an x to the 4th. And then negative 3x cubed times a negative 1. Negative times a negative is positive. 3x cubed. Let's try and fix that. There we go. And that is the final answer. Again, we can't combine these because they do not have the exponent. They do not have the same exponents. They are not like terms. Okay, next, example 4. We're going to do example 4, and then we're actually going to save example 5 for later. So example 4 will be the last one we're doing in this video. So I'm distributing the 2x. Again, it is a monomial times a trinomial. So my answer is going to be a trinomial, since there are no like terms to combine here. Okay, here we go. 2x times 3x cubed. 2 times 3 is 6. X to the first times x cubed is x to the 4th. 1 plus 3 is 4. 2x times 2x squared. 2 times 2 is 4, so plus 4. X times x squared is x cubed. And then 2x times negative 4x. 2 times negative 4 is negative 8. X times x is x squared. Again, that is our final answer because they are not like terms, so I cannot combine them. You can only add or subtract things that are like terms. Okay, you're just going to save example 5 for later. You don't, if you want to try it, you can, but you don't have to. So example 5, you can leave blank for now. We'll do it together. But I do want you to do all of page 7. So 1, 2, 3, 4, 5, 6, 7, and 8. Again, let me point out, when you're looking at these, 1, 2, and 3 are monomial times monomial. So you'll multiply your coefficients, then for each variable, you will add the exponents. 4, 5, 6, 7, and 8 are the distributive property. I know that because there is more than one term here. That's why I know that. Okay? Okay, so good luck with that. We will check them in class. Be careful. Pay attention to your details.